Okay, guys, so here are some notes that you need to jot down on your handout. To solve multi-step equations with variables on both sides, we follow these steps where we first combine like terms. And then second, we clear the fractions by using those parentheses and multiplying by a fraction. Then third step is add or subtract terms to both sides. And this is kind of a little note we need to put under there is so that the variable occurs only on one side of the equation. Trying to keep it positive if we can. And then step 4 is use inverse operations to isolate the variable, starting always with addition and subtraction. So here we've got the variable z, and we've got 10z here and negative 4z here. So we're going to start by combining like terms. So I'm going to combine this positive 10z minus 4z first, combining that to be a positive 6z minus 15 equals. Now on the other side, we've only got one z, but we have two constants. So we have a positive 8 and a negative 15. So it's 8 minus 15, which would be a negative 7 minus 2z. So now we're just going to get the variables to one side since they're on opposite sides of the equal sign. So looking here, we could do minus 6z, or we could do plus 2z. So I'm going to do plus 2z to keep it positive, plus 2z. This one goes away. I'm left with 8z minus 15 equals negative 7. Solve like normal, starting with addition and subtraction. Plus 15 plus 15. 8z equals negative 7 plus 15. That's 8. Opposite of multiplication would be division. Divide by 8. I have z equals 1. Okay, so I want you to try this example 8 on your own, very similar to the one we just did. Okay, so first thing you should have done is combine like terms. So I'm focusing on just one side of the equal sign. I've got a 12z here and a negative 4z. So combining those, 12 minus 4, that's 8z, and I still have the minus 12 equals, again on this side I have two constants, 6 and a positive 32. Adding those two together, 6 plus 32, that's 38 minus 2z. So since we have a z on this side of the equation and a z over here, we need to add or subtract to get them onto one side. So I could do minus 8z, or I could do plus 2z, plus 2. Again, I want to keep it positive, make my life easy. Plus 2z, plus 2z. This goes away. I'm left with 10z minus 12 equals 38. Solve like normal. Plus 12, plus 12, 10z equals 50. Divide both sides. I'm left with z equals 5. Okay, so here we've got a fraction example. So the first thing we need to do is clear fractions. We can't combine any terms right now with all these crazy fractions. So looking at our least common denominator, we've got 5, 5, 4, and 10. So the number that works with all of those would be 20. So I'm going to multiply everything here by 20. So 20 times the y over 5 plus 20 times 3y over 5 minus 20 times 3/4 equals 20 times y, which is just 20y, minus 20 times 7/10, which multiply it times every single term in here. So, using simplify before I multiply, dividing both these by 5, that's 1. This is 4. So 4 times y, that's just 4. Goodness, 4y. Again, simplify, dividing by 5, that's 1, that's 4. 4 times 3y, that's 12y. Okay, here we're subtracting. 20 and 4, divide them both by 4, that's 5. 5 times 3, that's 15, equals 20 times y is just 20y. Simplify before I multiply, that's 1, that's 2, divide them both by 10. 2 times 7 is 14. So now I'm going to combine like terms. So I've got a 4y and a positive 12y on this side. Combining those to be 16y minus 15 equals 20y minus 14. So now we can just solve like normal, making sure to get our variables on one side. So at this point, which direction do you think we should go? Well, we could do minus 16y or minus 20y from both sides. Again, I want to keep these positive, so I'm going to do minus 16y and then minus 16y. So this cancels. I'm left with negative 15 equals 20 minus 16 is 4y minus 14. Solve by isolating the variable. Plus 14 plus 14. I'm left with negative 1 equals 4y. Divide by 4, divide by 4. That goes away. It's just y equals negative 1/4 or negative 0.25. Either answer would be acceptable. Okay, so go ahead and try this example 10 by yourself, making sure to clear the fraction, looking at your denominators, and finding the least common denominator. Okay, so looking at this, the least common denominator I'm going to use is 24, so I'm going to multiply everything here by 24. So 24 times the y over 4 plus 24 times the 5y over 6 plus 24 times 3/4 equals, well, this is just 24 times y, so that's 24y minus 24 times the 6/8. Okay, making my life easy, I'm going to simplify before I multiply. So 24 and 4, I can divide them both by 4, leaving me with 1, 6. 6 times y, that's just 6y, plus, here, 6 and 24, I can divide them both by 6. 1 and 4. 4 times 5, that's 20y, plus, again, I've got that 4, so 1 and 6. 6 times 3 is 18, equaling, I already have the 24y, minus, simplify, 24 and 8, I can divide them both by 8, leaving me with 1 and 3. 3 times 6 is 18. So before I start to solve, I'm going to combine like terms. So on this side, I've got a 6y and a 20y, combining them to be 26y plus 18 equals 24y minus 18. So again, we have variables on both sides of the equal sign, so we need to figure out how we're going to get those to one side by addition or subtraction. So I'm going to subtract 24 from both sides, keeping those numbers positive, 24y, 24y. So this cancels out, left with nothing. Here I'm left with just 26 minus 24 is 2y plus 18 equals negative 18. So again, isolating the variable, solving like normal, I'm going to subtract 18, these cancel, I'm left with 2y equals negative 18 plus 18, that would be negative 36, I'm dividing by 2, I'm left with y equals negative 18. Okay, so here I've got some word problems. You're going to be writing an equation first. So first you're going to write an equation. And then second, you're going to solve. So here we've got Daisy's Flowers sell a rose bouquet for $39.95 plus $2.90 for every rose. That's pretty important. Do we know how many roses right now? No, we don't know how many roses. And then it says a competing florist sells a similar bouquet for $26 plus the $4 for every rose. $4.50 for every rose. So we have to find the number of roses that would make both florist bouquets cost the same price. So it has to be Daisy's Flowers equaling the competing florist flowers. They have to be equal. So let's write an equation for Daisy's Flowers, knowing that it's $39.95 plus $2.95 for every rose. Well, again, we don't know how many roses. So let's use for rose the number of roses. Let's use R. So Daisy's, her expression would be $39.95 plus the $2.95 for every rose. And then the competing florist, they sell $26 plus $4.50 for every rose. So again, we want to find a number that would make both of these expressions equivalent. So let's set them equivalent to each other in an equation. So 39.95 plus 2.95R equals 26 plus 4.5R. Now we have to find the number of roses that could fit in for R that would make both sides of the equal sign true. So here's our equation here. So now we have to solve. So we have a variable over here and a variable over here. We have to get them on one side in order to solve. Again, we want to keep it positive. Oops. We want to keep it positive, so let's subtract 2.95R from both sides. This one goes away. I'm left with 39.95 equals 26 plus, subtracting there, 4.50 minus 2.95 leaves us with 1.55R. And then this is just isolating the variable. So I'm going to get rid of this 26. Get rid of this 26. This goes away. I'm left with $13.95 equaling 1.55R. This is multiplication, so I gotta divide. When you do 13.95 divided by 1.55, you get 9 equals R. So that tells us that 9 roses in the bouquet would make both those bouquets equivalent prices. So the two services would cost the same using 9 roses. Great, you're going to try this word problem example 12 on your own. You need to first write an equation. And then second, solve for that variable. Okay, so we've got Marla's gift basket sells a muffin, or Marla's gift basket sells a muffin basket for $22 plus the $2.25 for every balloon. And then a competing service sells a similar muffin basket for $16 plus the $3 for every balloon. Find the number of balloons that would make both gift baskets the same price. So we've got Marla's, and then we've got the competing. So writing an expression for each, at Marla's cost $22, and then additional $2.25 for every balloon. And I'm using B to represent the number of balloons. And then the competing service sells us, it's 16 plus 3 for every balloon.